Alrighty, so here we go. So, your exam is on Thursday. These are the things that you have to know. You have to memorize that 1 mole is equal to this many particles or atoms or molecules or formula units. You also have to know that 1 mole is equal to the molar mass. These top two are the most important to know for this exam. So, starting off, how many formula units does sodium chloride have? I know that sodium chloride is NaCl. And I know that formula units is also referring to this conversion factor that I have right here, particles. Formula units is the same as particles. The reason why it is formula units is because sodium chloride is an ionic compound, meaning it is made up of a metal, which is my sodium, and a non-metal, which is my chlorine. So, how many formula units does sodium chloride have? Well, I know that every single compound, doesn't matter how big or how small, will always have 6.02 times 10 to the 23rd formula units. That is just a basic memorization right here. 1 mole is equal to 6.02 times 10 to the 23rd particles, atoms, molecules, formula units. In the case of sodium chloride, it is formula units. All right, moving on. Circle the false statement. All right. First statement. 12.011 grams of carbon is equal to 1 mole of carbon. If I look at my conversions up here, I have that 1 mole is equal to my molar mass. This right here is the molar mass of carbon. So the molar mass is equal to 1 mole. That is correct. A mole of oxygen has the same mass as a mole of nitrogen. If you look at the periodic table, the mass of oxygen, we already said that the mass is equal to the moles from this conversion right here. So the mass of oxygen in the periodic table is about 16 atomic mass units, and the mass of nitrogen is about 14. So if they're saying that a mole of oxygen has the same mass as a mole of nitrogen, well, that doesn't make a lot of sense. 16 does not equal 14. Let's move on to the next one. A mole of nitrogen contains 6.02 times 10 to the 23 atoms. Well, based on our conversions up here, that is also true. A mole of anything contains 6.02 times 10 to the 23rd particles. So that one is correct. Last but not least, the mass of 1 mole of a compound is the molar mass. That is correct. That is the definition of molar mass, where 1 mole is equal to the molar mass. 1 mole is equal to the mass of a compound, element, whatever it is. That is correct. So the only false statement here is B. The masses will change if you're talking about different elements. All right, now we're moving on to some math. How many atoms, let me scroll up here a little more. Oh, too far. There we go. How many atoms are in 0.75 moles of CH4? The first thing that we have to do here is acknowledge that we are going from moles to atoms. And when you are doing that, the conversion that you need to know is this one. 1 mole is equal to 6.02 times 10 to the 23 particles, atoms, molecules, whatever the question is talking about. So, I know that in 1 mole, there is, why is this so tiny? I think I have it. There it is. In 1 mole, there is 6.02 times 10 to the 23rd. What are we talking about here? Atoms. 1 mole is equal to this. All right, so now I can set it up. I can see that it says in 0.750 moles, this is what I start with. Now I have to cancel out this unit, so I'm going to go back to this drawing thing. If I want to cancel out moles, I have to multiply by moles at the bottom. So I'm going to have my moles at the bottom. And I know that in 1 mole, there are, it's going to be hard to draw, 6.02 times 10 to the 23rd. Wow, that's really bad. Sorry, guys. That says 23rd. Atoms. Atoms. Boom. All right. So now I can see that my moles will cancel out, and all that I am left with is atoms, which is what the question was talking about. So I am ready to do my answer for this. Okay. So if these numbers are next to each other, which they are, I can just straight up go and do the math and calculate it. So 6.02 times 10 to the 23rd times 0.750 is equal to, there we go, 4.52 approximately times 10 to the 23rd. So for these problems, you want to identify what your final answer should have, which is atoms, which I need to write here because I'm leaving a naked number. There it goes. Atoms. So I wanted atoms and I got atoms. I wanted atoms and I got atoms. And I started with moles. Started with moles here, started with moles here. I wanted to get rid of moles, so I put moles at the bottom so that these could cancel out, which they did, and then I just used my conversion and got my answer. All right, let's do another one. How many moles of H2O are contained in 54.0 grams? Ooh, so this one wants me to go from grams all the way to moles. And if I look at my conversions up top, I can use this one. 1 mole is equal to my molar mass. That means I need to find my molar mass. So if I have 54.0 grams of H2O, I need to multiply this by something that cancels out my grams at the bottom, right? Because grams are at the top, they also need to be at the bottom, and gives me moles at the top. Grams and moles, that is my molar mass. So I have to find the molar mass of H2O. I know that if I look at my periodic table, my hydrogens have a mass of 1.008, and I have 2 of them. Ooh, that's a bad 2. I have 2 of them, so I have to multiply that by 2. And I know my oxygen has a mass of 15.999. So now I have to add 1.008 times 2 plus 15.999, and that is equal to 18.015. And what is the unit? Grams per mole. That is always the unit of molar mass. Okay, so now I finally have a little conversion here that I can use to plug in to this part of my conversion. So if I start with 54 grams of water, I know that there are 18.015 grams of water in 1 mole. And that is going to equal to, when I have grams at the top and grams at the bottom, that's going to cancel out. And I only have moles left, which is exactly what I wanted. So I have moles left. And now I only have to solve the math. So 54 is on top, 18.015 is at the bottom, so I have to divide 54 divided by 18.015. And that is 2.99, which approximately is 3.0 moles. 2.99 rounded up to 3 moles. There it goes. And there it went. I went from grams of water. I needed to find my molar mass so I could convert from grams to moles. And I have my answer in moles. So always look at what is the final purpose of the question and what you start off with, grams and grams here, so that you can see what you need to do to cancel out units. And then just solve the math. All right, this next question is pretty simple. I like it. So all you're going to do is you're going to count each of your atoms. So I have carbon atoms and I have hydrogen, and I have, oh man, hydrogen atoms. So I have 1, 2, 3, 4 carbon atoms. I have 4 carbon atoms, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 hydrogen atoms. So I know that empirical formulas mean that you want the least amount of ratio within your answer. So my final answer is going to be something C subscript something, H subscript something. So I have to fill in these little numbers, right? Whoops. So right now, what I got is I have 4 carbons and I have 10 hydrogens. I can still get this down to a lower ratio if I divide by 2. So if I take the 4 and I divide that by 2, and I take the 10 and I divide that by 2, that is going to equal 2, and my H's are going to equal 10 divided by 2 is 5. Then I need to ask myself, can I reduce this even more? Can I divide 2 and 5 by the same thing to make it into a smaller ratio? And the answer is no, I cannot. 2 and 5 is the smallest it'll go. So now I know that I've reached my empirical formula. I have, let me get my smaller here. I have 2 carbon atoms and I have 5 hydrogen atoms. This is my empirical formula right here. It's not C4H10 because that is a molecular formula. It is the actual size of my compound. It is C2H5 because it's the smallest ratio that I can go. Okay, cool. And we are going to stop this video right here. So number 1 through 5, this is the first part of your unit review. Go on and watch the next part for the next problems.